In this worksheet, we're finding measures or angles of isosceles triangles. So there are really a couple different types of isosceles triangles. An equilateral or equiangular triangle is isosceles. Isosceles is defined as having at least two congruent sides. So a regular isosceles triangle on the left has congruent base angles and two congruent sides, but an equiangular or equilateral triangle is also isosceles. We call the congruent sides of an isosceles triangle the legs. The congruent angles we call base angles, and the other angle we call the vertex angle. So they want us to fill in these measures without using a protractor. So if we look, angle A is 45, that means angle B must also be 45. And 180 take away 2 45s is 180 take away 90, which is going to give us 90 degrees for the measure of angle C. So this triangle ABC has congruent base angles. They're both 45 degrees. And the vertex angle C is 90 degrees. So we fill that in. Next triangle, A and B are the base angles. They're both 71 degrees because they have to be congruent. 2 times 71 is 142. 180 take away 142 leaves 38 degrees for the vertex angle at C. Fill that in. Here's number 3. For number 2, we've got a 76 degree angle. 2 times 76 is 152, which leaves 28 degrees for the vertex angle. If we do 180, take away 152. So we have the two congruent legs. Opposite the legs, we have congruent base angles, and triangle sums gives us 28 degrees for the vertex angle at C. In the number 4 triangle, we've got a 65 degree base angle, so the other angle must be 65 degrees. And 2 65s is 130. 180 take away 130 gives us 50 degrees for the vertex angle at C. Okay, let's look at the other side of the page now. This really deals with measuring with a protractor. And what they're doing here is figuring out like 110 degrees is out to side CB from the left-hand side. And then they look at the difference of 70 degrees, which is to side CA, and that leaves 40 degrees in between. We're primarily going to use triangle sums for the 100 if we were given the angles. For these, they don't really give us the angles because they're really kind of set up to measure them. So we're just going to go through and pick a measure for angle A and assume that that's what it is. So for triangle 1, we're going to assume that well, first of all, that AC and CB are congruent, and we're going to let the measure of angle A be 35 degrees. So it means that B is 35, and 180 take away 70 leaves 110 degrees for the vertex angle at C. If we go over to number 3, going across, let's see, what will we do for that one? Let's let angle A say be 50 degrees. So it means angle B is 50 degrees. And if we do 180 take away 100, which is twice the 50, we end up with 80 degrees for the vertex angle at C. So again, isosceles triangles, AC and CB are the congruent sides. The opposite angles, the base angles, are congruent. Angle A is congruent to angle B because they're opposite those equal sides. And then we can calculate that X is 50 degrees for that one, since they all have to add up to 180. And 50 plus 50 plus 80 makes the 180. Looking at number 2, let's see, we'll assume that the measure of angle A is, let's see, what would we do? More like 60 degrees. So we've got 2 60s, which is 120. Take that away from 180, we get 60. So it doesn't look like it, but with that 60-degree angle at A and B, we actually have an equilateral or equiangular triangle, which means that all those angles are going to be congruent to each other. So A, B, and C all have to be 60 degrees. Or we could do 180 take away 260s, which is 180 take away 120, which gives us 60 degrees for the vertex angle. For number 4, let's let angle B be 70 degrees. So that means angle A must be 70 degrees. Together we have 140 between those two angles. It takes 40 more degrees to make the triangle sum of 180, so that must be the measure of angle C. Must be 40 degrees. 180 take away 140 gives 40 degrees. Then for number 5, it asks us, in each of the isosceles triangles in 1 and 2, are the measures of A and B equal or unequal? When in an isosceles triangle, the base angles are congruent, and A and B are the base angles, so they must be congruent.